Hey, and welcome to our explainer. We are absolutely surrounded by computers, right? From these massive supercomputers that predict weather patterns all the way down to the smartwatch on your wrist. But what's the actual difference? Well, in this explainer, we're going to cut through all that tech jargon to classify these machines and find the fundamental DNA that, connects every single one of them.
So let me just start by asking you a quick question. How many computers have you used today? Seriously, think about it. If you said one or two, you're probably way off. Your phone, that's obvious. But what about your car's engine control unit, your smart thermostat, even your microwave? They are all highly specialized computers. And it's that incredible variety that means we really need a good way to sort them all out.
So here's our game plan. First, we're going to sort computers by their underlying technology, how they actually think. Then, we'll dive into the classic way of looking at them by size and pure power. After that, we'll uncover the core traits that they all share before finally digging into the one thing that even the most powerful computer on Earth just can't do.
All right, first up, let's group these machines by the fundamental way they were built to work. This isn't about how fast they are or how big they are. This is really about the soul of the machine itself.
The first type is what we call an analog computer. And honestly, the best way to think about this is like a dimmer switch for a light. It's not just on or off, it has this smooth, continuous flowing range of brightness. An analog computer works just like that, by measuring continuous physical things, like voltage or pressure, to solve a problem in real time.
And on the complete other end of the spectrum, you've got the digital computer. So to stick with that analogy, this is your standard light switch. It is either on or off, a 1 or a 0. There's nothing in between. Every single computer you use on a daily basis works this way, by crunching billions of these distinct, countable numbers.
And looking at them side by side really shows you the crucial difference. It all boils down to this. Analog computers measure, while digital computers count. And that one little distinction, it explains everything else. It's why digital can be 100% accurate and repeatable, why it's more reliable, and at the end of the day, why it's the tech that powers our modern world. Okay, so what happens when you need the best of both worlds? What if you need that real-time speed and the pinpoint accuracy? Well, that's exactly where the hybrid computer comes in. Its whole reason for being is to fuse those two worlds together.
A perfect and really important example is a hospital's intensive care unit. You see, analog devices are great for continuously measuring a patient's vital signs, things like heart rate and temperature. That real-time analog data then gets converted into digital numbers for the other system to analyze. You get analog speed with digital's precision, right when it matters most.
All right, let's switch gears. Now we're going to look at our second classification method, which is all about physical size, the cost, and just raw processing power. We're about to go on a little journey from the absolute titans of the computing world all the way down to the machines that we carry in our pockets. Now, this hierarchy isn't just about size for the sake of size. It really tells a story of specialization. We're going to start at the very top with supercomputers, which are designed for these singular, massive tasks, and then work our way down the chain to the super versatile microcomputers that have basically become an extension of us. At the absolute peak, we have the supercomputer. These things are monsters. They are all about raw, focused power for one single, complex problem, and they can process billions of instructions every second. How? Through massive parallel processing. That just means thousands of processors all working together on one task, whether that's modeling a star or forecasting a hurricane. Now, where supercomputers are built for complex math, mainframes are built for handling transactions. Think of them as the central nervous system for a huge global bank or an airline. Their job is to reliably handle thousands of people all trying to access a massive shared database at the same time, with a huge focus on never ever going down. Kind of slotting in below the mainframe was the mini-computer. This was the mid-range server that brought that kind of centralized computing to smaller companies that couldn't afford a mainframe. You don't see them as much today, but they were a really crucial bridge that made multi-user systems way more accessible.
And that, finally, brings us home to the microcomputer, named for that single microprocessor chip at its core. I mean, this is the category that completely changed the world. It covers every PC, every laptop, every smartphone. It democratized computing and put a ridiculously powerful machine right into the hands of a single person.
Okay, so we've sorted them by their internal tech and by their sheer scale.
But what really connects a city block-sized supercomputer with the phone in your pocket? Let's break it all down to the absolute core characteristics, the fundamental DNA that they all have in common.
It really all starts with speed. I mean, because these things operate at the speed of electricity, their internal operations are, for you and me, basically instantaneous. We are talking about millions and now even billions of instructions every single second.
And that incredible speed is matched by almost perfect accuracy. A computer can do the exact same calculation millions of times with zero mistakes. But that mechanical perfection comes with a huge, huge catch.
And here it is, the foundational law of all computing. Garbage in, garbage out, or GIGO. See, a computer is only as accurate as the instructions and the data we give it. If you feed it bad info, it will flawlessly and diligently follow your instructions to give you a perfectly calculated but completely wrong answer. The error is almost always human.
Now, this same blind obedience to our instructions is also what gives it such an amazing storage capacity. A computer can hold these massive libraries of information and pull up any piece of it perfectly with no decay, whether it was a second ago or a decade ago.
And that perfect recall is combined with what you can only call inhuman diligence. It's a machine. It doesn't get bored, it doesn't get tired, and it never loses concentration. The millionth calculation it performs is done with the exact same speed and precision as the very first one, which is why it just blows us out of the water at any repetitive task.
And finally, all of these traits, the speed, the accuracy, the memory, the diligence, they all combine to create unbelievable versatility. The very same machine can go from playing a cinematic video game to controlling a factory's robots to modeling financial markets, all depending on the software we tell it to run.
So we've established that computers are just incredibly powerful tools. They're fast, they're accurate, they're tireless, they're versatile. But for all of that power, there is a fundamental line that they absolutely cannot cross. This is the ultimate limitation that separates every single computer from the human mind.
So here's the bottom line. A computer has zero intelligence, no IQ, nothing. It's a perfect follower of instructions, but every single one of those instructions, what to do and in what order, has to come from a human being. It doesn't feel anything, it doesn't have hunches, and it can't make a judgment call based on experience. It is a powerful, powerful tool, but it's one that can't even turn itself on without us. And this brings us to one last really critical question. We know computers can do any task we can break down into logical steps for them. They're amazing tools that just amplify our own abilities. But knowing that they have no real judgment, no wisdom, and no feelings, what are the things we should never ask them to do? That's the question for us, not for the machine. Thanks for joining us for this explainer.